Alright, this is where, in my opinion, we enter into interesting territory, memory allocation. So, the idea is about how you allocate memory space to processes, right? So, we know every process has its own address space, which is this list of memory addresses belongs to you. You and you alone can access these memory locations, right? Who allocates these? Obviously, the operating system is going to oversee and guide this process. Now, you cannot randomly take a bunch of memory addresses and allocate it to the first process that comes asking you for space, right? There are things to be kept in mind, there are constraints to be followed, and the idea is there should be minimal wastage of memory space. So, minimal wastage in terms of different things, as in, one, if a process needs only 5 units of memory, you should try not to allocate any more than that. So I'm not saying allocate exactly 5. That might lead to other types of wastages, which we will come to in a minute. My thing is, as much as possible, try not to allocate an excess. So sometimes it might be necessary to allocate 7 units even though a process needs only 5. We are going to look at an example. But if you can make do with 7 units, then don't try to allocate 10 units. So that is one sort of wastage. Second is, when you allocate memory like this, when the fragments are disjoint, when they are not continuous, the empty spaces in between, try to minimize those. Try to minimize the number of unallocated free memory locations in between, so that sort of wastage also doesn't happen. This is one thing. These are two types of wastages which can occur, which it might not always be possible to minimize both. You will have to find a middle ground. There will be a trade-off. The idea is, try to be as judicious as you can while allocating memory to different processes, and when I say be judicious, these are the things you need to keep in mind. Also remember that context switches are costly and time consuming. I will explain this sentence in a while, right? So we will look at this variable partition scheme for memory allocation now. So I hope the basic idea of memory allocation is clear. You have to allocate address space to processes, trying to make sure that there is minimal wastage of memory space. Alright. So for that, one of the techniques we use is what we call the variable partition scheme for memory allocation. So what happens there is, sorry for the interruption. So yeah, what happens there is, as and when a process comes requesting for some amount of memory, you are going to allocate whatever it asks for. So if process 5 is asking for 6 units, you give it 6 units. Then P8 is asking for 10 units, you give it 10 units. P2 asks for 5 units, for example, give it 5 units. They might be continuous. Generally, initially you will allocate continuously, and then let's say process 8 finishes, then it goes off. Now P5 is still working, so memory is allocated to it. P2 is still working, so memory is allocated to it. P8 has finished what it wanted to do, so that memory has been cleared and P8 has been terminated. Now this space which is free is called a hole, right? So now when another process P9 comes asking for some memory space, you will try to check the holes first and see if whatever P9 is asking for can be accommodated within this hole. Let's say P9 is asking only for 1 unit and you have some 10 units free here, then you can very well accommodate that, right? So you put P9 over here and the remaining 9 units or whatever, there is a hole. Similarly, if another process comes and if it's asking for 2 units, maybe you can put up that process in this hole. But if a process comes asking for 17 units, this hole is not sufficient. So you will go to the end of whatever you allocated, and after that, after process 2, if there is extra space, you will try to allocate. So note that the memory allocated to a process should be continuous. So between process 5 and process 2, you can have a gap. But process 5 itself cannot be in 2 disjoint places. So you cannot have one part of process 5 over here in the first blue hole and another part over here. Because we have this idea, right, that it starts from base and goes up to base plus limit. The checking also happens based on that. So if you have one segment here and then another segment here, then this checking technique will not produce the results you want, and it's just going to be a lot of chaos. So whatever address space is allocated to a process, that should be one full chunk. Between two processes you can have empty space. So yeah, that is variable partition scheme, where you keep allocating, you try to fill in the holes only if it is not possible to fill the holes. If the process coming in wants more space than a contiguous hole, then you will go to the end and you will try to allocate in the remaining places. Now ignore this word fragmentation for time being, we will come back to it very quickly. We will see how to allocate, right? So I said you check the holes and you allocate if they are conducive, but within that also there are different ways in which you can allocate. So the first is first fit, best fit, worst fit. First fit is you start from the top, you start checking first hole, second hole. Whatever is the first hole which is big enough to accommodate your process, put the process there. So let us say a process P1 is coming now in this condition. It wants 12 units. I'll check the first hole. Let's say it is 5 units. The second hole, let's say, is 14 units. Now the first hole is not big enough to accommodate P1. The next hole, this is big enough. So I will directly put P1 here. I will not look at what are the holes after this. Is there a hole which is exactly 12 units? Is there a hole which is better suited? I will not look at anything. Find the first hole that is big enough and put your process there. That is first fit. Best fit, find the smallest hole that is big enough. So if P1 needs 12 units, let's say this hole is 14 units long and this one is 12 units long, then I will choose to put it in the 12 unit long hole. So find the smallest hole which is greater than equal to the size required by your process. That is best fit. And worst fit is the exact opposite. Find the largest hole which is greater than equal to the size of your process and put the process there. So these are different approaches which you can use while mapping a process to a whole, right? So these are different strategies. Now generally first fit and best fit have proven to be generally better than worst fit, not always, generally. So there are special cases where worst fit actually works. There are counter examples. There are cases where first fit works better. There are cases where best fit works better. I'm not going to go into those specific cases with too much depth, because again, this topic does not require that much deep diving, and also because if I take it into too mathematical a direction, it is possible that some of you might be confused. So the idea I'm trying to convey here is, you have processes which have memory allocated to them. When a process leaves, that memory space is freed up, that is called a hole. A new process comes in, you want to try to fit it into a hole which is greater than equal to the size of the process, because you cannot split a process into two parts and allocate some memory here, some memory here. It has to be a contiguous block. Now for allocating in that manner, you have multiple approaches. First fit, find the first suitable hole which is greater than equal to your process size. Best fit, find the smallest hole which is greater than equal to your process size. Worst fit, find the largest hole. So these are different strategies. Generally, first fit and best fit are better, but overall, can we make a claim that one of these is the optimal strategy? Not really. It depends on case to case. It depends on your memory, it depends on the hole size, depends on the process size. So that is your memory allocation. Now the problem with this scheme is fragmentation. So fragmentation is something we saw here also, and I said we'll come back to it. So the problem with this variable partition scheme, basically like putting processes into the free holes, there's a problem, and it is fragmentation, which we'll discuss in the next segment.